For number 10 and 11, both dealing with velocity functions, it says the velocity function in meters per second for a particle moving along a line is given by this equation. Find when the particle is moving to the right, left, or stopped. All right? It's the velocity that tells us if it's moving to the right, left, or stopped. If the velocity is positive, it's moving to the right. Left is the velocity is negative. Stopped is when the velocity is 0. So we already have the velocity. What I would do is make a v or a velocity number line. And they're just going from 1 to 6, all right, by the given domain. And so we want to figure out when the velocity equals 0. So if we set the velocity equation equal to 0, lots of ways to figure out when that equals 0. Factoring, quadratic formula, graphing, I'm going to factor it. Let's see, t minus 4, t plus 2. Okay, so this equals 0 at 4, and this equals 0 at negative 2. Since t is time and not between 1 and 6, or negative 2 is not between 1 and 6, that one doesn't make sense. But 4, we'll say that's there, is 0. So we know that the particle is stopped at 4. Okay, so then we just have to figure out what's going on here, what's going on here. So we're going to do that by plugging something between 1 and 4 into the velocity. Let's try 2. And something between 4 and 6, let's try 5 into the velocity. All right, so if we plug 2 in there, let's see, 2 squared is 4, minus 2 times 2, which is also 4, so that would be negative. If we plug 5 in there, 5 squared is 25, minus 18 would still be positive. Okay, so the particle is moving to the right between 4 and 6. To the left between 1 and 4. And it is stopped at x equals 4, or t equals 4. Okay. B says find the average velocity of the particle. Right. The average velocity of the particle, we're going to use the mean value theorem for integrals, 1 over b minus a times the integral from a to b of the velocity. Right. So our interval is 1 to 6, so 1 over 6 minus 1, the integral from 1 to 6 of t squared minus 2t minus 8 with respect to t, or 1/7 times 1/3 t cubed minus t squared minus 8t, evaluated from 1 to 6. Okay, so we're going to plug 6 in there, get a number, 1 in there, get a number, and subtract those, either multiplying by our 1/7 along the way or at the end. And sorry, that's 1/5, I mean. And that 1, when you multiply by 1/5, you get an answer of negative 2/3 meters per second. Okay. C wants the displacement of the particle. The displacement of the particle is the integral of the velocity. Integral of velocity is displacement. All right. So we are integrating that function again that we just did. So the only thing that's missing is that fraction out front. Okay. And we are evaluating that from 1 to 6. So it would be 1/3 t cubed minus t squared minus 8t. Plug in 6, plug in 1, and subtract them, and you get negative 3.3 meters. 3.3 repeating meters. Not surprising that those are negative. Here our particle is moving to the left more than it was moving to the right. Okay, hence the negative average velocity and the negative position. And then D, find the total distance traveled of the particle. This is a little bit trickier because we've got to separate the time when it was moving to the left, because that will calculate as negative, from the part when we were moving to the right, because that will calculate as positive. So that would look like this. The integral of the velocity from 1 to 4, again we're going to break where it stopped and turned around, plus the integral of the velocity from 4 to 6. Okay. Now we've integrated this function twice now already, that's that value, so we would do 1/3 t cubed minus t squared minus 8t from 1 to 6. Oh, and I forgot that this is going to calculate as negative, so we actually want the opposite of all of this, because we don't want negative. We're finding total distance, so whether you're traveling to the left or to the right, it's still distance, plus 1/3 t cubed minus t squared minus 8t from 4 to 6. This one should be from 1 to 4. 1 to 4 and 4 to 6. Okay. Again, we plug in 4, get a value, plug in 1, get a value, subtract them, take the opposite. Here we're plugging in 6, getting a value, 4, getting a value, subtracting them, and then adding these two totals together. And you should get 32.6 repeating meters. All right. Number 11 says the velocity of a car was read from its speedometer at 10-second intervals in the recorded table. A says use the midpoint rule to estimate the distance traveled by a car. Well, to use the midpoint rule, we need to know the midpoints. So we're going to make this one of our intervals, and then this one of our intervals, and then from 40 to 60, one of our intervals, from 60 to 80, and from 80 to 100. And then we're actually going to be using actually the y coordinates of these, but these points that are in the middle, hence the midpoint. Okay, so each of those intervals there are 20 seconds long. I'm just going to put the unit in there so you can see something we have to do at the end. And then we're just multiplying by the heights of the rectangles. So 38 plus 58 plus 51 plus 53 plus 47. Again, using the y coordinates. Those y coordinates are in miles per hour. So when we add all these up, multiply it by 20 seconds, we end up with 4,940 second miles per hour. Okay. Kind of a strange unit. So we don't want second miles per hour. So we want, usually you want the distance in miles. Okay. So we've got to get rid of some of this stuff. So we know that in 1 minute, there are 60 seconds. So that would get rid of the seconds. Okay. Now we want to get rid of the hours and the minutes. So we're also going to multiply by the fact that in 1 hour, we're going to put that on top because we want to get rid of it on the bottom. There are 60 minutes. I didn't organize this very well, but this is minutes on the bottom, minutes on the top, hours on the top, hours on the bottom. Okay. So when we figure all of that out, we'll have an answer in miles. And that answer should be about 1.372 miles. Right. B is with the trapezoid rule. All right. So remember, that's where we have to double some things because we use them twice. Okay, we're going to be using like this. This would be one trapezoid. This would be another. This would be another, etc. Okay. So the trapezoid rule starts with a half. Each interval is 10 seconds wide. This first height, 0, is only the height of one trapezoid, plus 2 times 38 plus 2